Welcome to Earth Science. Take 3. Let's see if this works this time. So tomorrow's your density quiz. Congratulations, you've made it. Or maybe today if you're waiting to do this tomorrow. Thursday is your density quiz. Not going to exactly look like this sheet, but you should be pretty comfortable with what's on the sheet if you're going to make it. So first things first, this will be given to you. This is also on the front page of the reference tables. Always there for you anytime you need it. Let's talk about what you saw here. So here's a basic setup of your lab. This question might look familiar. It was in the notes. How do you do the following things? Well, you put the mineral on the balance, you move those little sliders till it's balanced, and that's it. That's your mass. I'm not going to write that. I think you guys get the gist. Volume, you see what the volume is. It could be any random number. You carefully drop it in, and you see how much it goes up by. So if it went from this up to this, neither one of those numbers on their own are very important. It's the amount that it went up by, which in this case looks like 10. Density is going to be just do that, mass divided by volume. And 60 divided by 10 is 6. That's it. So this drawing has basically 4 different things, 2 different liquids, 2 different solids. How can we do density and tell which is the most and the least? A is the most dense, that solid. It sank all the way to the bottom. This I will write, I suppose. More dense things sink. Absolutely critical to this test and like the rest of Earth science. What if we have hot flowing rock in the mantle? The more dense stuff's going to sink, the less dense stuff going to rise. What if we have cold air coming down from Canada and warm air coming up from the Gulf of Mexico? Less dense warm air is going to rise, cold air is going to sink. It happens throughout this whole entire course. So we're beating it to death here deliberately. Less dense things float. So pretty much if you're going to go in order from the most dense A to whatever this darker liquid is, whatever this lighter liquid is, to D. Why do hot air balloons float? Now, I had people, this was on that little classwork quiz that you should have done by now. I had a lot of people tell me, well, they're filled with hot air. I'm like, yeah, I know that. That's why they call them hot air balloons. You kind of just told me the question, right? That's like, I don't know. That's like if I worked at Subway and you came in and I said, hey, what kind of sandwich would you like? And you just said, sandwich. Doesn't really tell me much, right? Why is it that this happens? Hot air is less dense. That's your shortest, sweetest, precise answer. If I were to smash a rock into 2 pieces with a sledgehammer, as one does, what happens to these things? Well, the mass of that piece will get smaller. That's a smaller piece. The volume of that piece will get smaller, but the density, which is a function of the ratio of mass to volume, stays the same. Take something, this rectangle, break it in half, the density of each half will stay the same. It doesn't change. However, and I explained this in terms of making a snowball, and if you haven't heard that, I really recommend you go back to the first notes video to get that little snowball analogy. Maybe that will help on the quiz. But what if you compress? I still have my balloon here from the notes. What if you compress? Well, if you squish it, the mass really of the balloon itself and the air that's in it should stay the same. The mass doesn't change. I had some people tell me it decreases, and I get what you're thinking, but it's actually the same amount of stuff. The volume decreases. We're jamming it into a smaller amount of space. And since we're doing that, it's going to be more dense. You're taking, I think they did it with these blue little dots here, right? Let's pretend that's the air inside the balloon. You're taking it and taking the same number of them, but jamming them into a smaller amount of space. And therefore you have an increasing density. So this increases. That's important. But up here with the rock thing, since you're just evenly breaking without compressing or expanding, the density stays the same. All right. So this is going to get us to, I believe there's a way. Yep. I'm going to give me one more page. Just looking for some blank paper here, which this is doing nice and quickly. All right, there we go. So got to be able to solve these. There's just no way around it. Again, this timestamp link will take you right to 430 seconds into this video, which is right when I talked about how to do these. Okay? It's always going to be take this equation that's given to you, and I'm going to shortcut it by actually writing density, D for density, equals M for mass over V for volume. Take those, and you're always missing one. Which one are you missing? Plug the other 2 in for numbers, right? So when you need a density, that's in my book the easiest, because it's just like, we'll just use the equation. Density equals mass over volume. So 587 divided by 149.4. Grab a calculator, boom, 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 type them in there, and you should get 3.93. I haven't started busting chops about labels yet, but we're going to get there. If you start paying attention now, grams divided by milliliters is grams per milliliter. All right, on this one, I'm missing a volume. So we've got, plug your other two numbers in. If you're confused on these, I'm telling you, it's the easiest way to do it. And some people ask, like, do I have to write this all every time? You have to give me a correct answer. Some people can do the algebra in their head. Some people can just say, oh, let's see, volume must be then mass over density. You can do that in your head. If you can do that in your head, grab a calculator, do it, and get an answer, fantastic. If not, it's still okay. You're still going to make it, but I really recommend taking your time. The thing that I don't want is that you're getting these questions wrong because you're just like trying to guess. So 1.54, that's my density, equals a mass of 45.5 over a volume, I don't know what that is, over V, or over X, whatever you want to put there. All right, I'll change color slightly just for the heck of it. You can always put a number over 1 and then cross multiply. So 45.5 times 1, which is 45.5, equals 1.54 V. If you're in algebra class, I'm sure you've done many of these. Divide whatever's next to the variable there to cancel it off both sides. Over 1.54 over 1.54, and that's it. Job done. That's canceled. Grab a calculator, 45.5 divided by 1.54, and your calculator is going to tell you it's 29.54. Your brain's going to tell you milliliters. Again, my big concern is the numbers today. Don't sweat the label so much if we're still figuring out the numbers. Okay, let's do one more like slow form. Now I've got a density of 2.22, and that's equal to some mass that I don't know. So m, or again, if you're like locked in algebra mode of using x's, use x, over 889.9. Okay. Always legal to put something over 1. Do that. Cross multiply. Like that. It's just a random click there. Cross multiply. That means m, because it's m times 1, equals that times that. So grab a calculator and type them in there. And if you do, you're going to get 9. I'll even throw a comma in there. 1975 points. If you round, that's fine too. 1,975.578. And again, I guess I probably should write this, right? That is by doing 2.22 times 889.9. Okay. The next one is just do that again. So density is mass over volume. And I can't give you more than this equation when you come in, but some folks end up just figuring out that it's always D is M over V, V is M over D, and M is D times V. Now that was a lot to like throw at you real quick, right? I recommend the slower path going through the algebra. But again, it's whatever works for you. So I'm going to just go straight to answers here just to keep this video on the short side. Come see me if you want any help with any of these. Here, 44.4 over 44.4 is 1.0, which also, maybe this will come up, is the density of water. Because by definition, a gram is the amount of water it takes to fill a milliliter. So this number and this number will always be the same with pure water. Over here, let's do, it's 28.12 milliliters. And down here, it is 221.85 grams. No way you're going to make it through this quiz if this is still a mystery. All right, that means 10th period, come talk to me. Shoot me an email. I'll be on it at some point later tonight, early tomorrow. Come see me early in the morning. Come see me before class starts. This has got to happen if you're going to make it. Okay? And I'm sure you can. We've all been looking pretty good with more and more practice. Thanks for watching. Good luck. You're going to do great.